Hello, everybody. Welcome to this session on absolute values in algebra. It's a topic that I've seen many people struggle over the years that I've been in the industry, and today my goal would be to take away a little of that fear. So if you just follow through the session and try to, imbibe all that we try to give to you here, you're gonna find yourself way more confident towards the end of the session on this tricky topic. So, before anything, I'll take the opportunity to introduce myself. I am Shweta a quant subject matter expert at eGMAT, and with us we have Harsha, another expert who's going to support us throughout the session today. All of the questions that I might not be able to take during the live session, Harsha will answer you if you put your questions in the comments. Let's keep the comment box very lively. Everybody, keep it super interactive. That is the best way to learn. The one time that I would not want you to interact is putting in answers in the comment box. You will be given polls to answer. That's the only time we're off the comment box. Otherwise, we're talking throughout. Okay, so the purpose of the session is to help you understand that if you want to ace GMAT Quant, then it's not about doing thousands of questions. It's about, first of all, building the right foundations, building the right conceptual foundations, and then learning structured approaches to solve your questions. No shortcuts. We don't believe in shortcuts at all. They work one time, they don't work another time. You don't want a method that is not foolproof. You go into the exam, you want to go with that confidence that no matter what question comes, I will be able to tackle it. So, this structured approach, this methodical approach is what we swear by, and you're going to see how that does wonders to your accuracy. This is an important slide. It's the flow of the session. Everybody should understand this nice and clear. We're going to start with the warm up section. This is just to warm ourselves up. We are going to have 5 questions here, easy questions, 500 to 600 level. Now, through the solutions of these warm up questions, I'm going to help you build your conceptual foundation. A lot of you might already have this foundation, but it might be rusted because of, lack of, regular access to it or regular practice to it, or you might know the concepts but they might not be super strong. So this is where we'll just recap all of the concepts. Then this sprint is where you test yourself. You're going to have 3 questions in the first sprint, and then another sprint with 3 more questions. Throughout the session, I'm going to give you feedback and takeaways. Now, takeaways are going to be general, which is for everybody, and they're also going to be person specific. You make a certain mistake, then it's your job to make a note of that. You have to understand, this is the kind of mistake I make. Unless you identify the mistakes you make, you're never going to be able to correct them. Never just brush off an error as just a silly mistake. You just take away the chance to correct it forever. You have to identify, and today I'm going to tell you how, through process skills, you will have exact names for the mistakes you make. Okay, so that feedback will come throughout the session. I will discuss faltering points, where typically people mark this choice and why they mark this choice, and if they mark this, then what is it that exactly they missed, which process skills they missed. You're going to hear me say that a lot. Process skills are nothing but the bridge between concepts and application. A lot of times we know concepts, we know A, B, C, D, but we still find it hard to write down a bat or a cat. So, that bridge between concepts and application is what process skills are. And these are the very reasons questions go wrong, if, of course, your concepts are solid. If you don't know your concepts only, then you can't even think about going and crossing this bridge to the application stage. So we are now going to begin with the warm up section, everybody. It's going to be basic questions, as I said. 5 questions you're going to have. You will have polls for every single question in the comment box. Click on that poll, mark your answer, and come back to the session. Nobody should write down the answers here in the comment box. You don't want to influence somebody else's answers, right? Everybody should have a fair chance of doing what they feel is correct to every question before we discuss the solutions. So here we're going to take you to warm up question 1. The link will be up here in seconds. Good luck, everyone. Okay, so we have the accuracy data for this one. As you all read in the comments, it's 85%. That's great. 85% of all people who attempted this got it correct. So that's good. Let's discuss this. And I know we don't have to pay too much attention into understanding the concept, but your approach might not be the best one. Let's see. Well, mod of x minus 3, modulus of x minus 3 is equal to 5. What is the value of x? Now, instead of me giving you the answer straight up, let me just ask you some leading questions. So I'll understand exactly what your current level of comfort is. So I want the comment box to be super lively, you have to be interactive. That's how I know what to stress on and what to not stress on too much, okay? So this is what we're solving. I'm just going to substitute my x minus 3 as z. So what is happening here is I had the absolute value of some number x minus 3 equal to 5. Instead of having x minus 3, I'm just calling this number z. So it's some number z whose absolute value is 5. Now you tell me this. Which of the following is true about z? Ankur, no answers in the comments, please. Now we are done with this. We're discussing this, but still all answers to be put in the comments, in the polls only. Right now, everybody, write down the answer to this question here in the comments. Choose a choice, 1, 2, or 3. What you know is that z is something whose absolute value is 5. That's all you know. Come on, I'm reading all your comments. Okay, three, 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 three. Okay, 4 people responded quickly, and the answer for all of you is correct. Okay, more responses. Wonderful. Now, when a number has absolute value 3, it means the magnitude of that number is 5. I'm sorry, not 3. Asim said 1. So, Asim, you changed your answer. All right, so absolute value of a number being 5 means, as I said, that the magnitude of that number is 5. What that means is, again, you forget about the sign for a while, forget about whether it was -5 or +5. Magnitude is 5 only. So then z is 5 or -5. Now, when I solve that and I understand that z is 5 or -5, I've also just represented it here on my number line. You see this first value, -5, and this is the second value. So these are the 2 blue points that z can take. Then, if z is 5 or -5, there's nothing more to do. Really, you know z was x minus 3. Put it back, bring it back in place. Don't just give your answer as 5 or -5. Anyway, that wasn't in the choices, but that could have been a trap for somebody who's under time pressure, somebody who's just rushing through this, and the very first answer you get so excited, you mark it. Okay, here you were safe because that wasn't in the choices. So you put this back, put this as x minus 3 is 5 or -5. These are 2 very simple equations you solve, and you get x as 8 or -2, which is choice D. Now, 15% of us did get this wrong. Okay, so all of you people who got this wrong, you can tell me in the comments what exactly you missed here. This is the first place. This is the base of the absolute value session, where it's just an equation. It turns into an inequality after this. So if you've already identified a conceptual problem, now is the time to fix it, because all further questions you might again make the same mistakes. So make a note of what exactly you missed here. Okay, so the answer to this is choice D. Now, this is another beautiful approach I wanted to give you. It's instead of doing all of that substitution and getting z and then solving it, this is the distance approach. What you really have to understand is that the final answer that you got, -2 and 8, if you just observe carefully, -2 and 8 are both 5 units away, where 5 is what you had as the value of your absolute value. -2 and 8 are 5 units away from 3. So it's an interesting way of reading absolute values. Read it. The moment you see these mod symbols, start reading with distance of, then x. Then this minus is what you read as from. So distance of x from 3. is equal to 5. So if it's the distance from 3, then you start with a 3. You make a 3 somewhere on your number line. And since you want the distance to be 5, you go 5 to the right and 5 to the left. That's it. This is how you get the value of your x without having to do any substitution whatsoever. Okay, I have a question. LHS and RHS, right side and left side, are both positive. So square and solve the quadratic. Definitely, that is another approach. So there are many ways you can solve a question, but these are the most efficient approaches that are going to work every single time. Okay, Himanshu says, mod of x minus a is 5. What to do when it's x plus a? You are going to see that in a question to come. I knew that would be a common problem, so I've written that question. Here, let's all go into warm up question 2. The link will be up here in seconds. Good luck. All right, so we have our accuracy scores here. Beautiful scores. 94% of you got this correct. Wonderful. So now, this was the first twist to our very simple first question. Instead of having an equal to, we now have less than equal to. So it's an inequality. Even now, you can solve it using both methods. First is where you substitute. So let me show you that first. I'm just going to take that as z. So what you have is that absolute value of z is less than equal to 5. Now here's a small question to you, everybody. Come on into the comment box and tell me which of these is true about z. What can you say about a number whose absolute value is 5 or less? There is a very small lag between when you put your answers and when I see them. So the moment I ask a question, put your answers. Okay. So we have 4, 4, 4, 4. Okay, we have people saying that it's 4, and that is correct. Very good. If a number has absolute value as 5, you saw that that number could be 5 or negative 5. But if the absolute value is also allowed to be less than 5, then you could go inside, you go within that range of 5 and negative 5. So that's absolutely perfect. And because of that, when you try solving this further, you can see how on the number line also I've represented the same thing between negative 5 and 5. Now you get this for your z, replace back your x plus 3, I'm sorry, x minus 3 here, it's correct. Now how do I get x from here? I'm going to add 3 on all sides. A sandwich inequality is what we call this, when it is three sides of it, but you don't solve it any differently. If you want to remove the 3 from this x minus 3, you want to add a 3, right? So you add it throughout. So on the left hand side it becomes negative 2, on the right hand side it becomes 8. And this is it, this is your answer, this is what you got in C part. Yet again, let me tell you how this would be done using the distance approach. See how I told you to read this? The moment you see the absolute values, read it as distance of x, the minus is read as from 3. Distance of x from 3 is less than equal to 5. So where is it from? Where is the distance from 3? So you start with a 3. Just put 3 on the number line and you want the distance to be 5 or less. So where is the distance 5? First of all, you go 5 units to the left, 5 units to the right to reach negative 2 and 8. But you're also allowed to have the distance less than 5. Distance from where again? From 3. So you're going to come closer to 3, right? So that's how it's this entire range between negative 2 and 8, which is exactly what you got in the first method as well. I hope everybody is absolutely clear with this. This was a very small transition from equations to absolute values to inequalities, and you saw how the approach does not change one bit. You have strong concepts, you know how this business works, and then you start working it, whether it's the substitution method or the distance approach. It worked here. It was very easy to work with your distance being 5. Now somebody asked what happens if I had, the distance is equal to 4x minus 3, then the distance itself is a variable. Now their distance approach does not feel as natural as this. I mean, it's very easy to go 5 to the right and 5 to the left. What if I say this distance was 2x? Then you go 2x to the right and 2x to the left, where you also have to think, okay, is my x positive? Because distance has to be positive. So there, the substitution approach and more methods become more natural. But yes, if you're careful, you can use the distance approach even then. Okay, let's all go into warm up. Question number 3. The link will be up here in seconds. Shashadri, I would not be able to take the question like this. I'm so sorry. I will try. We have questions such as this coming on. You feel free to write to us anytime. I'll help you. Okay, the scores are here. This time we have a 70% score, so lower than what we had for the first two questions. Let's see why. The only thing I changed here was, first of all, two things really. One was I changed the minus to a plus, and I changed the less than to a greater than. Now, again, I still want to give you all of the approaches. Even if you do not understand the distance approach, you should still be able to solve it. First time, if I substitute x plus 3 as z, I get this, that the absolute value of z, it's some number whose absolute value is 5 or more. Yet again, there's a small conceptual question for you all. Tell me this, which of the following is true about z? Okay, so the first time we have different answers. Shrikant says it's 2, and Mohak and AC say it's 3. Well, think about it. Shrikant, it's a common mistake to say what you did say. You thought that if the absolute value of z is greater than equal to 5, typically what people say is it's greater than equal to 5 and negative 5. Now, really, when you write down these 2 points, what you're saying is that z is greater than equal to 5, less than equal to 5, and minus 5. Why do I even need to say both things? If it's already less than negative 5, then it's anyway less than 5, right? This does not even make sense. Now, we also have people saying 4, that z is between negative 5 and 5. Well, focus here on the number line. Let me show you exactly what this is. So you have a number z, as I said, whose absolute value is 5 or more. Now, first of all, we've already seen it in the first question. Where is the absolute value equal to 5? So it's equal to 5 at two places, negative 5 and positive 5. That's it. Where is it going to be even more than that? You want the absolute value to be more than 5. If you go to the right side of 5, 6, 7, 7.5, we don't have that, they're integers, they're all going to have greater magnitudes than 5. Similarly, if you go to the left of negative 5, minus 6, minus 7, minus 7.5, all of them are going to have magnitudes greater than 5, which is what you wanted, right? So the region really is all of it beyond negative 5 and 5, on the left of negative 5 and on the right of 5. All of you who said 4, you've given the opposite answer of what we needed here. You thought, where is the absolute value less than equal to 5, which is what we had in the previous question. Now, though, you want it to be more than 5. You can always think about this. Okay, so Mohak says whenever we have a greater than equal to sign, then definitely we have two ranges. Not just a, it's absolute value of a. Because if I have, say, x greater than 3, that's just a single range. Everything on the right side of 3, right? Okay, Jyoti, we don't have a 5 here. There are just 4 options. I hope everybody understood what the first level of mistake was. I'm pretty sure that is why the trap choice here, choice C, had almost 30% votes, as you read in the comments. All of you people just did this one mistake that you saw here in the concepts only. So I wanted to break the question down before I show you the actual question. Now that we all concur on this, that it's either less than equal to 5. Oh, there is, yeah, it is this region that you see here, less than equal to negative 5 and greater than equal to 5. Then this is what we've written here in the form of z. Then finally, now that you have your answer in z, you replace back, you put back what it was x plus 3. So it's x plus 3 greater than equal to 5, or x plus 3 less than equal to negative 5. Then simply, how do you solve this? You want to get x from here, right? So you subtract 3 on both sides. So this one is going to be x greater than equal to 2, and this is going to be x less than equal to negative 8, which is exactly what you have here in choice D. Okay. How could it be greater than 5? No, Himanshu, z greater than equal to 5 or less than equal to negative 5. Oh, sorry, you meant the article A. Whenever we have a greater than sign, then definitely we have two ranges. Even now, Mohak, I have x greater than 3, as I said. It's still a single range. Okay, still very well done. We had 70% accuracy for this one. So this was a little above the previous two. Now here's the distance approach. How do I read this? Distance of x. Now, how do I get the from? Remember, I said what from was? It was that minus sign. Now, here, if I have a plus sign, I can't read the from that I meant. Somebody asked that question a while back in the comments. What happens if it's a plus? Well, this is what you do, you change your plus into this. It becomes absolute value of x minus of minus 3, right? Now try reading it. So the absolute value is read as distance of x from -3 is greater than equal to 5. So the distance this time is from -3. You make that on your number line. Now you see, where is this distance going to be, 5 or more? So you first find out where it is 5. So you go 5 on the left, 5 on the right. You reach -8 and +2. But that is only where the distance is equal to 5. You're also allowed to go beyond that. You are allowed to have a greater distance. So you go farther away from your -3. And so the range you get is this, on the left of -8 and on the right of 2. Okay, so great. Now, with this, let's go into warm up question number 4, everybody. Good luck. Didn't think this way, Manchu. I'm glad you understand now. Jyoti, as I explained, that was the trap choice. That is C, but the correct answer was D. Okay, we have the scores this time. It's 58%, so a lower accuracy this time. Let's see what happened here. So the question is, the absolute value of x minus 3 is equal to 3 minus x. Do you observe what the difference is between these two? Both of them have the difference of a negative sign. So if there's a -5 inside, then there's 5 outside. Which of the following gives the range of values of x? Now, here, let me ask you something very basic. Just observe here. If I say the absolute value of a number is equal to b, absolute value of a is equal to b, can you not say for sure that b has to be non negative? It cannot be negative because it is the absolute value of something, right? So this b is greater than or equal to 0. 0 is still allowed because absolute value of 0 is 0. Same story here, just compare this one with what you had in your question. You had 3 minus x in place of this b here. Now, because 3 minus x is the absolute value of something, it is greater than equal to 0. So if 3 minus x is greater than equal to 0, you get 3 greater than equal to x, or you can say x is less than equal to 3. So choice D is the correct answer. Okay. So we have this comment: A and C are both popular choices. Okay. So a lot of you marked A. So you thought that the only time this could happen, that the sign is changing, is if your x is 0. Well, think about it. If your x is 0, then yes, the absolute value of negative 3, and on the right side you have absolute value, you have no absolute value, it's 3 minus 0 0, they are equal. But is that it? It's this entire range, all of the values less than equal to 3 were to work. 0 is just one of them. Then C was another popular choice, which is just the opposite of what it had to be. Well, that would be the answer if I had this right hand side as x minus 3 only. So had I said absolute value of A is equal to A, which numbers have an absolute value equal to themselves? That's only if that number is 0 or positive. That's how you would have had C. So be very careful when you mark your answers. Now, this is a very, very small concept. You see what I just used? I just used the very definition of absolute value, that it can't be negative. But see how the accuracy for this was the lowest till now. So that shows that the concepts are not super, super strong. There is still scope. So make note of this. Make notes that you faltered here. Okay, let's all go with this concept done now to question number 5. Good luck. Mohak, please don't post any answers here. All answers in the polls only. All right, so we have the accuracy for this one. It's 64% this time, so low again. Let's see what happened. So, absolute value of a to the power x. So that is the complication you had here. It's not just a simple absolute value, but a certain power. But you know what would have made this simple? This 1. If you understand when is the power of something to the power something, when is that value equal to 1, you would be able to narrow this down easily. I'll just show you how. Look here, let's break this down into this simple conceptual question. Tell me what the answer is. Make sure that you read this carefully. I'm asking which of the following can be true, not must be, things that can happen. Let's start with this. I'm so sorry. We see there is great confusion here. We have very different answers coming in. A lot of people have said 3, 2, 4, 1, many, many different choices. So let's take this slowly. So, A, if it's 1, then absolute value of A is also 1. Now, 1 to the power anything, whatever x may be, 1 to the power 10, 1 to the power 20, 1 to the power negative 30, it is going to be 1. So, all those of you who did not think that 1 was true, that means people who marked 2 or 3, you did not use this very basic fact that 1 raised to the power anything is 1. Similarly, a is equal to negative 1. Even now, I'm anyway taking the absolute value of a, right? So, absolute value of negative 1 is also 1. So, it's still the same principle. Even now, it's going to be true. I'm not on mute anymore, Gopal. I hope everybody can hear me. Could you please just confirm? Everybody, can you hear me? There's probably some lag on your side. Okay, so as I was saying, please confirm if all of you can hear me. Yes, thank you. All right, so we've already seen how the first two can be true. Now let's look at the third one. X equal to 0. Okay, this time I have information about my power, not what the base is. Now say I have 3 to the power 0, or I have 10 to the power 0, or minus 5 to the power 0. All of that is 1. So if you didn't do that, again, that was a conceptual thing that you were missing. Whenever I have anything to the power 0 except 0 to the power 0, that's not defined, anything else to the power 0 is always 1. So all of these are possible. So the people who said 4 are correct here. For the others who got this question wrong, it could be because you did not consider this throughout, you did not work through this completely. Now, let me bring the question back. Let's discuss what we have here. So, you have absolute value of a to the power x is 1. And according to the cases that we just saw, we have a few possibilities. One is if a is 1, in that case, x can be anything. Two, if a is negative 1, again, x can be anything. Really, these first two cases are not doing anything different because both of them give you the same absolute value of a as 1. And the third case you saw was if x is 0, while a is anything non-zero, because if you have 0 to the power 0, again, that's not defined. So these are three situations in which it can be true. Now, in our question, we wanted to say which of the following is definitely true, must be true. So it could not have been these statements directly because these are all just could be true statements. They're true one situation, they're not true in another. Let's see. A, where A is 1, could be true. We saw how a could be -1. We saw how a could actually be any non-zero number. X is 0. Again, it could be anything, as you see here in cases 1 and 2. A cannot be 0. It cannot be 0 in the third case. Otherwise, a is free to be 0. Fourth choice, if x is 0, if the power is 0, then a can be any number except 0. And that's precisely what you have here in the third case. If your power anyway is 0, then you're free to have just about anything for a except 0. So the correct answer here is choice D. I hope everybody understood this. We had low accuracy here. Now, all of these warm up questions were to give you the concepts that you need throughout the rest of the session. So, write down in the comments what are your biggest takeaways still here? What are the things that you did not know and now they're back? Or things that you did know at one point in time but you had forgotten? What were the mistakes you were making? I want to see what everybody is taking away from here. And meanwhile, I will go on and talk to you about more things. Shrikant, what's wrong with C? I explained how A can be 0 in these. A cannot be 0 is what they're saying, right? So if A is 1, X is any number. You're right. A cannot be 0 is also true. Wow. That is wonderful. You guys are super careful when you're doing this. Very well done. Okay, now biggest takeaways, guys. I want you all to have 200% clarity in all the concepts that you saw here, whether it's using an absolute value equation, or it's an absolute value inequality, a greater than inequality, or a less than inequality. All of those things should be absolutely clear. Make sure you're 200% confident in them. Why? Because the actual GMAT questions are not going to be as basic as you saw here. They are going to be trickier. So, how do you get ready for trickier questions? Only when you're super strong with the basic questions. How will you build your foundation, your application skills on a weak foundation? Okay. So, if you did any of these questions wrong, even after our discussion, if you did not match all of the choices, the correct answers, then you need to spend some time on your concepts. Yes, Gopal, you're right. Okay, with this now, let me tell you about some other upcoming sessions that we're bringing for you. We keep doing these sessions to help you. Now, there is this GMAT strategy session on the 7th of August, Saturday, same time as today, which is being hosted by Rajat Sadana, the founder of eGMAT. So make sure you're there. You learn how to strategize your preparation. You have the link here in the comment box of how to register. Okay, GMAT strategy webinar again. Understand how to create a personalized study plan. Everybody starts from a different point. I mean, I could be very strong with inequalities but very weak with absolute values, or I could be very strong with geometry but very weak with number properties. Everybody has a different starting point. Even if two people say they're strong, it could still be 70% strong and 90% strong. Your path will be different according to where you start. So you need to understand the importance of planning according to where you're starting from. Okay, so this webinar is going to help you. You'll understand what metrics you need to track to understand that you're on track, or if you need to change things, these metrics are going to tell you that. What are the key metrics that bring success? You'll find all of that here, and the tips to score 700 plus. Make sure you're there and you learn a lot. Then the very next day, 8th August, you have another quant webinar, number properties this time, same time as today, which Atreya is going to host. He's a GMAT quant expert at eGMAT, of course. Now here you're going to learn how to solve NP questions using a single approach, one unified approach. We're not going to just confuse you with tons of approaches. Okay, this is the question, do this. That is the question, do that. No, you build the right method once, and that is for all. Okay, you learn common question types. You learn how to solve hard questions under 2 minutes. It's a common problem. So many people can solve it if only you just remove that timer. But that doesn't happen, right? So this is where you're going to learn how you solve things in time. And you will learn about common faltering points. What are the mistakes people make? With that, everybody, this is the first place where you are going to test yourself. So warm up questions are very basic questions, just conceptual questions, but this is where you'll have GMAT style questions. So again, the instructions are the same. You are going to get polls. Just mark your answers there. It's just 3 questions this time, and every question we'll solve once you're done with it. Okay, let's all go into the first question. Good luck. Okay, the scores are here. We have a 72% accuracy this time. Okay, let's discuss this. So, 72 is not very low. So, we're happy. Harsha, could you turn on the video? Okay, so this was a simple question. Let's see. Is x equal to y? Simple question. Are they equal? First statement, the absolute value of x is equal to the absolute value of y. And the second statement was x squared equal to y squared. And we read in the comments how A, B, and D are equally popular. So there was quite a lot of confusion then. Let's discuss this. Okay. Obviously, the question stem itself gave you nothing. It just gave you the question, are they equal or not? What we have first time is in this information in statement 1, that these are two numbers whose absolute values are equal. Now, all those of you who marked A and D, what you thought was, if two numbers have equal absolute values, they are equal. But are they? What about 2 and negative 2? They are not equal, right? They do have the same absolute value. So, people marking A and D, you miss this basic thing that x could be both y or negative y. These two numbers could be equal or negative of each other. So, the first statement is not sufficient. You had to consider all the cases. Then, for people marking B and D, you again made the same mistake here. I kept it here deliberately. Yes, Satyavrata, they give the same information if only we know what this means. So the numbers x and y have the same squares. Now, for two numbers to have the same squares, do they have to be equal? For all of you who said B and D, you did think they were equal, but no. What about 2 squared and negative 2 squared? Aren't they both 4? They are, right? So they don't have to be equal. They could be equal, 2 and 2, or they could have opposite signs. Okay. Shashadri says, is 0 times 0 equal to 0? Yes, 0 times 0 is 0. What is not defined is 0 divided by 0, or in fact anything divided by 0 is not defined. Okay, coming back here, so statement 2 also is insufficient. Then that way I'm actually already rid of A, B, and D. The only choices left were C and E. I would have been happier if the tie was between those two, but that did not happen. See now, statement one gave you x is y or negative y. Statement two also gave you the same thing, y or negative y. So even if you combine them, are you getting anything new? You're not, right? Both of them are saying x is either y or negative y. So even if I combine them, I still have the same thing. And even now, I cannot say for sure whether my x is equal to y. It could be yes, and it could be a no. So this is also insufficient, and the correct answer is E. All of the other choices, if you marked A, B, C, D, you missed considering all cases. Okay, that was the first process skill that I'm talking to you about, and how you can now talk about the mistake you make in actual terms. You would not have to say, oh, I was just silly, oh, I forgot about that. No, you'll say, I did not consider all cases. Once you understand that this is a mistake you make, say that happens on 5 questions, then it's a red flag. Then it's clear that you are somebody who misses all cases. You tend to just move on too quickly. You forget about thinking. You don't think about everything that is possible. So everybody here, I hope you understand. Yes, it's a 600 700 level question. Okay, correct answer is E. Pay very close attention to what you're doing. Consider all the cases that there are, and never just assume things are going to happen unless you have proof for them. Okay, here you go for sprint 1 question 2. The link is up. Good luck. Okay, just look at the accuracy this time. It's 22%. Let's see what exactly happened. Harsha, I'd really like to understand how people voted for different choices. I'll talk about the faltering points step by step. Everybody be very careful about this one. Yes, Pranay, it's surprising. Let's see. So, is A less than B? Simple question. The question stem gives you no information. It just asks you a question. Is it less than B or not? Okay. And then there are two statements. Absolute value of A minus B is B minus A, and A by B is less than 1. So we have this comment that C and D were equally popular. Oh, that's really, really varied, don't you think? C is for people who thought that individually the statements are not sufficient. You need them together. D is for people who thought each statement individually is sufficient. That's the most varied result I had expected. Let's see. Okay, so first question stem, as I said, gives you nothing. It just asks you a question: is it less than B or not? Is A less than B or not? Let's just keep it on the side and get ready with our statements. So, statement one says, uh, absolute value of A minus B is B minus A. I had prepared you for this one through a warm up question. How many of you actually remembered when you saw this that, oh, this is similar to what we had in the warm up? Just say why for yes if you did remember. Okay. So, what you really have here is two numbers, A minus B and B minus A, where both of them differ by just a negative sign. You multiply A minus B with minus 1, you're going to get B minus A only. Now, for these, we had seen earlier that really the way to work with this is very simple. You just think about the right hand side and you think, okay, it is the absolute value of something. Mark your answer here and I'll understand if this is already where you faltered. Jasmine, this is again under the 700 level because this was simple. Once we gave you everything, you will see how harder questions will be. Anuj says B minus A is greater than equal to 0. Yes. Therefore, B is greater than equal to A. We need not solve it further. Yeah, you're right, Anuj. That's perfect. People, come on, answer this. I already answered because of you, Anuj. This is where I was breaking the question down. Okay, we have mixed answers again. So we have 1, 1, 2, 2. Yes, Jasmine, very straightforward after the warm up. Okay, look here. Because B minus A is the absolute value of something, it is greater than or equal to 0. That means B minus A is greater than equal to 0, which is exactly what you see here in choice 2. Now, A minus B is negative, misses out the case that it could be 0 as well. That's why 1 is wrong for people who said 1. I hope you understand. Again, you missed a case. The very same process, scale again, considering all cases. Just see how the same things keep happening. Okay, Gopal says B greater than equal to A, not B greater than A from statement. Oh, you're answering, Anuj. Yeah, okay. So not we cannot say it's just strictly greater than 0. Okay. With this now, let's discuss the rest of it. As I said, B minus A greater than equal to 0 gave you B greater than equal to A, which is two cases. One, B really is greater than A, and two, B is not greater than A, but it's equal to A. Just look at this. Now, what was my question? My question was, is A less than B? Now, if they're equal, I'll say no, A is not less than B. And if this is the second case, then yes, A is less than B. You don't get a sure answer, right? So, people who marked D, so many of you went for D, you thought this was sufficient. I'm pretty sure you missed the 0 case. Did you? Even after the warm up, what does that tell us? We have to take feedback. And when I say make note of where you falter, I'm serious about it. It happens, we repeat the same mistakes, and then the scores never improve. Learn from past mistakes and see the magic happen. I've seen this so often now. If only you would learn from past mistakes. Okay, here statement 1 not sufficient. Let's go to statement 2. Now, for all of you who thought this was sufficient, you missed this little concept, which is that if you multiply or divide both sides of an inequality by a negative number, the inequality reverses. Okay, reverses it. That means if my B is a negative number and I multiply b on both sides, it's going to become a greater than b. It flips. So that was a conceptual miss that you had if you thought this was sufficient. Just look at this. If my b is greater than 0, yeah, this is how you got a less than b. This is why you thought it was sufficient. But if b is less than 0, it'll flip. So people who missed this concept, make note of this. Again, 22% was the accuracy. Very different stages you people could have gotten wrong at. Somebody got wrong at this stage, somebody got wrong at that stage. Keep taking feedback seriously. So again, this is insufficient. Now I combine both of these. Let's see what that gives me. Statement 1 gave me two cases. Either A is equal to B or it's less than B. Statement 2 gave me again two cases. Either A is less than B or greater than B. Just see the highlighted part. This is the only thing that can happen in both statements. When I'm combining my statements, what I mean is both of them should be true, right? So the only thing that's happening here is that A is less than B. So when you combine, you do get a sure yes, and your answer is C. Look at this for all of you who marked A, B, D. As I explained, you did not consider all cases. And for people who marked E, you came very close. You combined the statements also, but you just didn't combine them properly. You could not understand that, okay, two cases here, two cases here, there's only one case which is common. And that was the one case that you anyway wanted. So you could not use the information that you had. You could not take out the right meaning from it. So here you get which process skill you faltered at. It will be all cases for people who marked A, B, D, and would be E for people who marked you did not consider inferring everything. Asim says considered E. You marked E, you mean? That means you did not combine them properly. Okay, so be very careful about this, okay? Let's all go to sprint 1, question 3. This is the last question of the first sprint. We have another sprint coming in. Good luck. Okay, we have the scores here. 30% accuracy this time. So again, pretty low. Let's see what happened now. Okay. Z is an integer such that absolute value of z is less than 6. Now again, I have trained you on this through the warm up, that what do you do when the absolute value of something is less than 6, so that you're already ready for. Question is z positive? And then there are two statements. Again, before I read my statements, I need to work with the question stem. All of you make it a point that unless you're done with thorough question statement analysis, you don't go on, because later on you get stuck, then you miss out cases, you miss out constraints. Okay, so here question was this, and what do we have? We first of all know it's an integer. Secondly, we know that absolute value of z is less than 6. Now, this means that z is something between negative 6 and 6. Now, because I'm not allowed to have an equal to 6 here, you see the same thing here. These are strict inequalities. So, because it's an integer, anything between this, then all of the values are really these 11 possible values, starting from negative 5 going all the way till 5, including 0 on the way. Okay, so this is what I have from the question stem already. Please write yes, y for yes, if you got till here, if you at least extracted all the information that was needed in the question stem. While you type that, I'll go on to the first statement. A, C, and E were all equally popular, 30%. Okay, so we see how there's great confusion here. First statement is something that you were prepared for from the warm up. You saw how the distance of z from 2 is greater than 3. That's how you use it, right? So you could either use the distance approach, or you could use the substituting method. Any which way you solve, you should get the same answer. So say I substitute z minus 2 as t, so it's going to be mod of t greater than 3. Now, when is the absolute value of a number greater than 3? When it's either less than negative 3 here, or it's greater than 3 here. These are the two possible intervals for t. So then, once I get that answer, I just replace my t back by z. So one was this, right? T greater than 3. I just rewrite that as z minus 2 greater than 3. So this will give me z. Similarly, t less than negative 3. This interval here is going to give me z minus 2 less than negative 3. Now, how do I get z from both of them? Just simple addition, subtraction. And these are the two cases you get. Now, for people who thought that the first statement is insufficient because if you're greater than 5, yeah, z is positive. If it's less than negative 1, oh, it's negative, and you rejected it already. Then you forgot all that we did in the question stem. You did not use that analysis at all. What did we know? We already know z is a number from negative 5 to 5 inclusive. So if somebody says it's greater than 5, is that even possible? No, because greater than 5, the very first one will be 6, right? So I can't have a 6 here, so this entire case gets rejected. The only case you're left with is that z is less than negative 1, and of course the constraint from the question stem will bind you there as well, that it's something between negative 6 and 1, but this makes it sure that z is negative, right? So if you do not consider what you had from the question stem, you would make a mistake. So all values are definitely negative, and statement 1 is sufficient. Morg says, shouldn't A be the correct option? Let's see. We already have the first statement sufficient. Okay. Let's go on and see further. Yeah, A is the correct answer. So statement 2, mod of z is equal to 2. Which numbers will have absolute values equal to 2? Again, something you're prepared for. So z is 2 or negative 2. That means if it's 2, it's positive. If it's negative 2, it's negative. So I don't have a sure answer. So statement 2 is not sufficient, and the correct answer is A. Now, let's see here why you got it wrong if you did. So, for people who marked B, you thought that the first statement is not sufficient because you did not use the question stem. And you thought B is the answer because you did not consider all cases. You thought, okay, if the absolute value of Z is 2, then Z is 2. No, right? It can be negative 2 as well. Similarly, for people who marked C, you did not use what the first statement had. You again did not use the question stem, and that is why you thought the need to give it more information. Okay, again, D for people who did not consider all cases. So everybody who did not think A was sufficient, you did not use your constraints from the question stem, and you did not consider all the cases. Okay, it could also be -7. How could it be -7, Himanshu? Go back to the question stem. It is something between -6 and 6 exclusive. It cannot be -7. All right. With this, pay very close attention to what you're doing. Consider all cases. Don't forget the question stem after you analyze it. And if you did not analyze it, just started with the statements, then that's a big no no. Never do that. Okay. Let's go to the next section of this presentation, which is going to be harder questions now. I hope you all feel ready to go and solve these challenging questions now. Before that, let me talk to you about some beautiful offering, a very beautiful thing that we have for you, Quant 2.0. This session that you see today is just a very small trailer. It's just one session. Quant 2.0 is your ultimate solution to all your quant needs. It'll take you from the ground up and it'll prepare you for the exam. For people who would like to try this, use the link there. I'm sorry about the cold. So you have the link here. You can access the new quant trial. Just experience this for yourself. You'll only understand it when you spend some time on it. Now, this is a typical module structure. This is how it looks. Now, just look at the detail we have for just absolute values, which is what the session is on today. You start with 2 diagnostic quizzes. One is a GMAT skill diagnostic quiz, which is going to give you GMAT style questions. Then the other one is a concept diagnostic quiz. These 2 together will tell you there will be some people who will be good with concepts but not the GMAT skill. That means you have the concept but you don't know application. There will be people who will not be very good with both of them. That means for those people, concepts themselves are a problem, right? So that kind of feedback you get before you start the course, so you will know exactly what to do, what not to do. These diagnostic quizzes, once you take the course, is going to tell you, oh, you've scored really well, you're eligible to skip this file, or oh, you've not done very well, you do this file. Okay, so that is the kind of feedback just as a personal tutor gives you. And even better, this is what you get every 10 minutes. Okay, now these are all the concepts that you have. C1, C2 is concept numbers. Then we have learning activities and practice quizzes. Learning activities are where we teach you application, where we teach you the importance of process skills. Okay, this is what you should be careful about. This is what you had to look at. You missed this. This is where you do a question, you discuss it, you see the solution, just how it's happening in the session. A practice quiz is you're in the exam, you have a set of questions coming at you, you do all of them, and then you get the solutions. Of course, you don't get the solutions there, but here you do. Quant 2.0 includes 6 detailed courses. Everything that is there in Quant, you're going to get that here with more than 1,900 questions. It's enough to get you ready for the exam. You don't need any other questions, by the way. Let me say that up front. You have a lot of problem solving questions, data sufficiency questions, every kind of question you need. And just look how there are 40 diagnostic files. You diagnose what you need and then you work. Person A already gets an 80% in the diagnostic. He doesn't need to watch, all the 5 concepts that there are maybe. But person B, who starts with a 20, he has to watch the concepts. So you'll be able to plan your time better. You'll know what you need to do and what you can just skip. Now, if you do things correctly, you will get to your success. Here's proof, by the way. These are Q49 plus scores on GMAT Club, and this is just till 31st May of this year. So you see how 47 of the Q49 scores owe their success to eGMAT, and just look how the other numbers are really low. Well, data talks for itself. This is another one, not just quant, since verbal is anyway another very strong point we have, but now it's quant and verbal both for you. It's your complete GMAT solution. 700 plus reviews just the month of June, by the way. This is 26, and less than 1/3 is the next closest competitor, and then 1 each for when you go beyond that. Okay, so this talks for itself. We don't have to give you answers. I don't have to make up things. You can read and you can trust data to tell you more about this, to build your trust. Go to GMAT Club, go to eGMAT's YouTube channel. You're going to see a lot of success stories, and you will really find that motivation from them. You'll understand, oh, this person did it, I can also do it. So I'd really like you to watch all of that. Now, if you're somebody who's struggling with how to plan, how to start, you need to talk to a strategy expert, is what you feel, you need expert opinion, you can book a call with us, one of our experts. So you'll see the link here in the comments. Just find a mentor. This is free for even non eGMAT students, by the way. You're not paying a penny, but you get that beautiful, beautiful help. With this, everybody, let's get back. I just wanted to give you a breather before we went into more challenging questions. Okay, I hope everybody feels super ready for all of this. I'm taking you into sprint 2, question 1. Good luck. Okay, very nice accuracy this time. Considering what we did in the previous question, this is great. So that again confirms what I thought, that it really was the question stem analysis that you forgot to take forward. Now, here, let's discuss this. What is the value of x? And the correct answer, as you already know, is C. Let's see. Of course, the question stem gives me nothing. Okay, I just am given a question. Let me go to the first statement. Again, you're ready for this from the warm up. So, distance of x from 2 is equal to 5. So, I'm starting at a 2 and I want my distance to be 5. I either go 5 on the left or 5 on the right, and I reach negative 3 and 7. So these are the two possible values of x. Since when somebody says, tell me what is x, if you think, oh, I'm telling you what is x, I'm just giving you two choices. That's not how it works. In all questions where they want you to give them a value, it has to be a unique value. Okay, so this statement is insufficient alone. Then you go to the second one. This clearly is insufficient because you have a range coming in, but let's solve this. Distance of x from 4 is greater than 4. So the distance is from 4, that's what comes in the middle, but then you want this distance to be greater than 4. Where is this distance equal to 4, by the way? It's equal to 4 at 0 and 8. But I don't want it to be equal to 4. I want it to be more than that. So I go further away from this 4. So I go on the outsides. And what I get as a result is that x is less than 0 or greater than 8. There are infinite values here that x could take, and that is why this is again insufficient alone. Let me combine them now. Harsha, could you tell me what the next choice was? Did people go for E more than this? Because if you marked A or B or D, then you faltered at a more basic stage, which is something that came from the warm up section. Okay, combining the statements, statement 1 gave us that x is negative 3 or 7, and statement 2 gave us this. Now, when you combine them, do you understand that this 7 does not fall into any of these? It's not less than 0, it's not greater than 8. The only one possible is negative 3, because it does fall into this first class that x is less than 0. So when you combine, you do get a sure value, and the correct answer is C. A and E were the next popular choices. So everybody who thought A, I'm pretty sure it was that assumption I talked about, that you asked X, I told you it's either negative 3 or 7. That either is not when you call a statement sufficient, it should be a unique value. Okay. Now, if you marked A, you did not consider all cases, or as I just said, you didn't understand the question. If you marked B, then it's a conceptual problem, because it's a huge range that you got. You could not have gotten a unique value of X. C, of course, is the correct answer. If you marked D, then you faltered at both of these. You didn't consider cases, you didn't have strong conceptual foundations. Take this feedback seriously, you'll know what to work on. And if you marked E, you just could not combine these two. So you did not infer that this 3, this 7 anyway gets rejected. It does not fit into the second statement at all. So I hope everybody understood this. Be very careful. You see how none of these questions is like super tough. Once you're good, you're solid with your conceptual foundation, and you pay close attention to the process skills, you don't miss out cases, you don't miss out constraints, you translate your question properly, you combine information properly, you take out the right meaning, you're not going to falter. Concepts don't get difficult, application does, if only we don't have the right concepts. Let's go into question number 2, everyone. Good luck. Okay, the scores are here. Pretty low this time, 29% accuracy. Let's see what happened. This, I tried to set the base for this little piece through a warm up question. I'm sure you recognized this when you saw. But there was this added piece that PQ is positive. So, how you could have worked on that is that PQ, none of them is going to be zero because otherwise the product can't be positive. Let's work on this. So, first constraint that PQ is positive tells you that none of them is zero, as I said, and the two cases that exist are both positive or both negative. That's all that can happen. If one of them is positive and one is negative, the product will be negative. Now, this is what I get from constraint number one. I haven't yet used the second piece. Okay, let's see. The second piece again, the mod of p raised to the power q is 1. There are these cases. Let's go on the side first. First possibility is that mod of p is 1, in which case q could be anything. Mod of p is 1 actually means that p is 1 or negative 1. Both of them are allowed, and q can be anything. Mod of p negative 1, now that is not possible because it's a mod value. But otherwise, if it was not a mod value, then negative 1 raised to the power some even number would again give you 1. Okay, so that was another possibility, but not for us. Third, if the power is 0, but mod p itself is not 0 because 0 to the power 0 is not defined. So the only case you have left is this. Why? Because q is not 0. We know none of them is 0. So this case gets rejected. This case gets rejected because mod p can't be negative 1. So you're only left with this, that mod p is 1 and q is any integer. Now, let's come here. If mod p is equal to 1, then there are two possibilities. P is 1 and p is negative 1. In both of them now, q can be any integer. It doesn't have to be positive or negative, as you see here. Q can be any integer. So what you really had to find was what is the value of p, but clearly you don't get that value of p here, so you could not have anyway because we didn't go into the statements. So the conclusion here is that p is 1 or negative 1, and q can be either positive or negative. Q is just not 0. Okay, statement 1, mod of p is equal to p. Now, option A is the most popular as I read here. Let's see. If mod p is equal to p, then what you can say, again from a warm up question, that this p is greater than equal to 0. It's non negative. If p is non negative, then it's either 0 or positive, right? But remember, we said none of them is 0. That means the only thing you can say is that p is positive. And if it's positive, then from these two values of 1 and negative 1, you're only left with 1. So you did get a sure value. So A, statement 1 is sufficient. So A, all of you who marked A, you got this part correct. Statement 2 now. It is easy to look at it and reject it. Why? The statement is only about Q. My question is about P. Oh, I don't have anything about P, so this is out. If you did that, you rushed. You did not use the question statement analysis. So, what we know here is that Q is non negative again, but you know Q cannot be 0, so Q is a positive number. Now, if Q is a positive number, what can you say? P is also a positive number. That doesn't have to happen. One second. P, if we had mod p to the power q, then p could very well be negative. Even then, q would work, right? So, Harsha, what percent went for A? Let's see the percentage. Guys, very well done. I see this time, okay, 33%. It's still low, but you guys thought about this, that even now P could be very well be negative 1 because mod P anyway does not make a difference. Jasmine says, why is Q negative? When no, Q is not negative when this. These are two possibilities you have for P and two possibilities you have for Q. The correct answer for this is A, as you saw. We cannot say for sure what p is going to be, because if p is 1, even then 1 to the power any q, whether it's positive or whatever, it's still going to work, and negative 1 in absolute value is still going to work. Okay, so 33% is what we're going to take. Okay, all right, now let's go to the last question for the day, everybody. Let's try for a higher accuracy and put in everything that you've learned till now. Good luck. Oh, hey, 1 second. I think I missed something. 1 second, let's go back. We also had the constraint that PQ is positive. See what I did? I missed a process scale that I was talking about. If PQ is positive, then we already know they have the same sign. If they have the same sign, then if P is positive, Q is positive. If P is negative, Q is negative. So this is correct then. If Q is non negative and you're sure that Q cannot be 0, then Q has to be positive. But because PQ is positive, this also means that P is positive, and yes, P is equal to 1. So indeed, this was correct. There was no error. The correct answer is indeed D, and the accuracy is 29% only. Jasmine says if Q is positive, P would also have to be positive. Yes, Jasmine, because we're given that the product of these two is positive. You see what happened here? One constraint. Now, when I write down my error log, you should all create your error log. What will I write? I'll write, oh, I did this wrong because I missed a constraint, right? I will have an exact reason for why I did something wrong. Similarly, you should have an exact reason for whenever you do something wrong. Everybody who marked A, you did the very same thing that I did. And now that we did it real time, it would feel more natural to you that exactly this is what happened. Jasmine says overlooked that constraint. See, it's so easy to overlook something that the question stem gave you. Now that I did this, a lot of you would focus more on this, because it's easy to see when you see things happening on screen and you see, oh, why this, we just had that. But when we're under time pressure and we're solving things, we do tend to miss that. So Jasmine, for us, everybody, be careful about constraints. Okay, going to the last question on that positive note. Good luck. The answer to question 2, as we saw, was D. You would think A if you miss the constraint from the question. Okay, scores are here. 60% accuracy this time. Much better. Good. So this was similar to what you saw in the previous question. You still have the same cases for P and Q as you did have last time, and you still want to find out the value of P. But one thing that you also have here is that the absolute value of P is not 1. It is going to reject two of the cases you had, one of the cases really. Let's start with that. So in statement 1, in the question stem, you already have that the absolute value is not 1. What does that tell you about P? That P is not 1, nor is it negative 1, right? That's one thing that is for sure. Then this power thing being 1, you again have the same cases. Now this time mod of P equal to 1 is also rejected because we're given in the question that it's not 1. Case number 2 anyway gets rejected because mod of something cannot be negative, right? So the only case you're left with is this, that your Q has to be 0 and then P can be anything non-zero. Anything also, when I say, it still cannot be 1 or negative 1. P still cannot be that. So let's see. Overall, it's any non-zero integer which is not negative 1 or 1 because of the constraint in the question. It can be anything else. So it can be 2, 3, 10, negative 10, just about anything. Now, let's see what else we know. We also know that Q is 0, by the way. That is what comes from case number 3, right? E is the next popular choice. Let's see. Okay, so statement 1, use the information you have here from the question stem. It's going to make everything super easy. Since you know Q is 0, can't you just put the value of Q here, put it as 0? It's going to become mod of P equal to P. Now, this is something you've seen. What can you say about P? Because it is the absolute value of something, it has to be non-negative. So it's either 0 or positive. But I already know it's none of these values. It's not -1, it's not 0, it's not 1. So anyway, the greater than equal to 0, the 0 goes. Only thing you're left with is that P is something positive. But then again, it can't be 1 because 1 we have already rejected from here. So any other positive value it can take. But what did I want? I wanted the value of P, a unique value, which I did not get. So statement 1 is insufficient. Now just ignore this. Statement 2, again I know the same thing. I know Q is equal to 0, so the absolute value of Q is also going to be 0. What I get is 0 is equal to P minus 2. P is 2. This was super simple. If you would just use the question stem properly, you would get the exact value of P that you were looking for, and the correct answer is B. Now we had 60% for this. Now the next popular choice, as we saw, was E. People who thought that even when you combine them, they're not sufficient. When statement 2 alone was sufficient. That's a big miss, wouldn't you say? Just use what you have from the question stem. Now, these are what you missed if you marked any of these. If you marked A when you thought that the first statement was sufficient, remember we got P is any positive integer. What you probably did was, out of these three you saw what is positive and you just took one. So what it could not be, you took that as what it could be. The same thing could happen for D. E is a conceptual problem. That means you could not work with so much of information together. This was simple small pieces of information, but we still got stuck. Aditya says, in the previous question, why can't both of them be? I don't remember the previous question. Arsha, could you please take that? Okay, coming here, B is the correct answer. Okay, now let me just talk about a few more sessions that you're going to have today. Please write in the comments, what are your biggest takeaways still here? What are the things that you learned, things that you had forgotten, things that were rusted, and what is it that you're really taking away? Make sure you go and experience the free trial for Quant 2.0. You wouldn't want to miss that. Now, 7 a.m. PST, same time as today, we'll start this GMAT strategy session on the 7th of August. Rajat Sadana, the founder of eGMAT, is going to do this. He's going to help you strategize your preparation. You need a plan when you're going on a journey such as this, okay? So make sure you plan things right. 8th August, the next day, you have a GMAT number properties webinar, which Atreya Roy is going to conduct, another GMAT quant expert at eGMAT. Then here you're going to learn how to solve hard questions in time, in GMAT time. It's not just about getting things right, it's about getting them right in the right time. You'll see where people make mistakes and what you can do to correct. That is it. Thank you very much. We're also putting the feedback form here. Please put in your feedback. Tell us how you liked the session. What would you like us to do next time? What more would you like to see? And so on. It was very nice to see you all here today. Thank you for joining.